listen, first of all, we're doing conversions of both points and equations. And here's the formulas that go from polar to rectangular. And people get confused about which formula to use. Look here, if you focus on one formula, you know r and theta. I mean, it's only work if you knew r and theta, because then you have these two, you can calculate the third. I know it's kind of obvious here, but here you're given r and theta, so this is your formula, r cosine theta. So write this down. You do r cosine theta to find the x, do r sine theta to find the y. Before you do these problems, before you start, you really should figure out which quadrant your point's in, because when you're done, it's supposed to be the same point. It better be in the same quadrant. That's a good check. Which quadrant is this point in? And it's the first quadrant, not just because that's first quadrant angle, but because you have first quadrant angle paired with a positive radius. It takes you into that direction. So yes, it's quadrant 1 point. Now do the math. Cosine of pi over 3 is 1/2. So you get 1 there. And so sine is square root of 3 over 2. So you get square root of 3. So it's positive 1 comma square root of 3, and we're done. And by the way, they're both positives first quadrant, so that's good. And these are easy because you just plug in the formula and just don't make silly mistakes. Next one. X is negative 5 cosine of 45 degrees. And y is negative 5 sine of 45 degrees. Although, like I said, before you do that, you really should plot the point. Not accurately, just get the right quadrant. So 45 degrees faces this way, but which quadrant is the point in? Third, so put the point there. And like, be careful with this stuff. Like right now, when I evaluate these trig functions, I'm evaluating at first quadrant angle. So cosine of 45 is positive square root of 2 over 2. And actually sine of 45 is the same thing. But then I do the rest of the formula, negative 5 times that, and I'll just write the coordinates. You get negative 5 radical 2 over 2 for the x, and same thing for the y. You can't simplify, so we'll just leave it like that. And if the x and y are both negative, it's in third quadrant, as it should have been. So like I said, be careful. The angle in this problem was a positive angle, but the point was third quadrant. So when you, all right, do you want to do the next example or the last one? Or I'm going to do one of these. Okay, let's do this one. First of all, let's plot this point. Which quadrant does that angle point into? Good, you're going backwards more than half a circle, less than 3/4 of a circle. So yeah, it's the second quadrant angle. And that's a positive radius, so it is a second quadrant point. So I can be careful. Now, so we're just going to do the radius times cosine of the angle, and then the radius times sine of the angle. And frankly, you already have the picture here. My picture wasn't perfect because really it should have been, the reference angle is pi over 3, isn't it? If it doesn't matter, or 60 degrees. I'm saying the coordinates are negative 1/2 comma square root of 3 over 2, right? Now, what I'll show in other classes is, like here, if you wanted to, you could rewrite this using even and odd properties. Just watch. You don't have to do any of this, but because it's even, you can rewrite that as just plain cosine of 240. Because sine is odd, when you make the 240 positive, you put a negative sign out there. If you wanted, you could do that. Or you could do, and just make a note, that was even, using even and odd properties. Or you can do coterminal angles. What's coterminal to negative 240? So if you prefer, re-express it as cosine of 120 and sine of 120, using coterminal angles. Or just draw the angle they gave you, and as soon as you know the coordinates, use that. Okay? So any of these will do. Just be careful. Notice this one, it actually changed the quadrant. All right, I'll just use this one since I have it sitting here. So cosine of 120 is the negative 1/2 I have sitting there. No fraction bar. And so that's -2, and then positive sign is positive there. That's 2 radical 3. And so -2 comma positive 2 radical 3, which looks right for a second quadrant point, doesn't it? All right? All right, by the way, you can check these in the calculator. I didn't look it up. I think it's in the math menu. But, or actually I think there's, I don't know. It's there. If you want me to show you, I'll look at it and we'll figure it out. Now, look at this. Going the other way around, where you're going from rectangular, which, by the way, how do you know these are going from rectangular? Because if you just focus on this one formula, if you knew polar, all you know is r, that's not good enough. You knew, if you rectangular, if you knew x and y, you plug these in, you have one thing missing. See what I'm saying? That's how you know these are going from rectangular. But my main point is that these aren't nice formulas, not really formulas like the other ones. The other ones, you plug in r and theta, they spit out the answer. It's only one answer. Here I'm saying, when you solve this, you're going to get plus or minus. And when you solve this, like if tangent is positive, you get first and third. If it's negative, you get second and fourth. You don't get an angle, you get multiple angles. And then you have to decide which numbers to use. Okay? So it's not going to spit out the answer. Skip this. All right, this one. So, look, they gave us x and y. And once again, x squared plus y squared equals r squared. We'll start with that. Just do Pythagorean theorem. Everyone find it? They're all on there. It's just kind of copied oddly. So you get 8. So r is the square root of 8, really plus or minus the square root of 8, or 2 radical 2 when you simplify that radical. And listen to me. If I have the choice, I'll pretty much always use the positive radius. Actually, here it asks for 2 pairs. You need to give 2 anyway. But I'm saying, remember, there could be negative radius. The radius could be negative. And besides, if it's a like multiple choice question, the correct answer may use a negative radius. Now for tangent, you do y over x, -1. So it's going to be pi over 4 for the reference angle. But it's second and fourth quadrants. What is this second quadrant angle? That's right in the middle of the second quadrant. Yeah, 3 pi over 4. And then the fourth quadrant angle with the same reference angle. Okay, look, I'm saying my other formula is that tangent equals y over x. And let me say again, that formula is helpful to us because what do we know? We know x and y. And so when you plug x and y into this, all you get left unknown is theta, so that's good. That's how the formula should work if you choose the right formula. And so I plug in y and x, I get -1 here, and then these are the angles where tangent equals -1. Now, I skipped something. Josh, which quadrant is that point in? Second or fourth? If x is positive and y is negative. So write that down. Good. Since that's the case, anyone tell me which of the angles would be better to choose? The second or fourth? The fourth. If you pair, the point is in the fourth quadrant. So your best bet is to pair the fourth quadrant angle with the positive radius. That's the correct answer. But you could also rotate away from it, rotate 3 pi over 4, and use a negative radius. Those coordinates hit the same point. Oh, yeah, thank you. I think that's a little bit of room here. Now it's correct. So let's, well, it depends on the directions. A lot of times it just says convert, find polar coordinates to this point. If it just says list one pair of polar coordinates, then pick. There's technically, with polar, once again, there's technically an infinite number of choices. Really, these are the only 2 you get here. Let me stress again, this is a fourth quadrant point, which means if you did this, you're wrong. That angle points in the fourth quadrant. Negative radius means the point this is the second quadrant point, which means it's wrong. So listen, if you lifted this and listed this, and that's all you did, I'll give you a point maybe. But you can't just put all the different combinations of this. You have to choose, okay? And so pick an angle and pick the appropriate radius to go with it. And for that matter, watch this. What if I did negative pi over 4 as my angle? I could do that. Which radius would I pair with it? The positive one, because this is a fourth quadrant angle, so I pair with the angle that the radius that points towards it. Okay. All right, one more. I'll get you started. Do Pythagorean theorem first. That's just 1, and that's just 3 when you square those. So you get 4, and square root of 4 is 2. So go ahead and finish it. You do y over x, you get this, which works out to be a positive. And your tangent values look like this again. So pi over 3 is the reference angle. And we're looking for tangents positive, so it's first and third. So the first quadrant is pi over 3. What's the third quadrant angle? Good. All right. Brianna, give us one pair of valid coordinates. Actually, first I forgot. Which quadrant is that point in? Now, Brianna, give us a pair of polar coordinates that work. No. Let me plot what you said, okay? You gotta be careful with this. Negative pi over 3 takes you there in the fourth quadrant. Pair with that negative radius would put that point, these coordinates for this point, in the second quadrant. Can I? If I keep the negative radius, which angle should I use? No. The answer is pi over 3. Let me put both. Here's the answers. Okay? Now, look. Where is the point? In the third quadrant, right? So remember, we're trying to hit this point, which is roughly here. The y value is bigger than the x value, right? I mean, absolute value is bigger, so it's... But I'm saying we're trying to hit this point. Your two options are either rotate towards it, and which of these two angles rotates towards it? The third quadrant angle, right? So pair the third quadrant angle with the positive radius, because you rotate towards it, and the positive radius takes you towards the point. That works. Or this one, if you draw it, you rotate pi over 3, and then you're facing away from the point, but the negative radius takes you to the point. And so that's the way it works every time. Wherever the point is, pair the angle that points towards it with the positive radius, and the angle that points directly away from it with the negative radius. And you're done. Okay? I'm not going to do these. They're calculator problems. You can just do the same formulas with the calculator. All right, you have this on your paper. It should be the next blank. It has quadrangular, points. This is one of the 4 points. Okay? I put them all together on yours. So listen, just watch, and if you want to draw these, you have to draw several all in that little area. This point is right here, right? How do I get to using polar? Well, one way is to not rotate at all, and then just go out 3 in the direction I'm facing. Another way would be to face away from it. So if I rotate, I'm trying to get to this point here, but I face this way, and what do I put here? It would work. I would list both those, though. You have to put it like to the right. Yeah. And there's infinite number of other choices. If I did 3 comma 2 pi, 2 pi would face the point, pair of the positive radius would work. Okay? Let's try the next one. First of all, where is this point? It's above the pole, right? So we're trying to get there. How much should I rotate? Pi over 2. The most sensible thing is to rotate pi over 2. And how far is it? 2. There's the good answer. But if you wanted to, you could rotate due south paired with the negative radius. And so you're facing south, but you back up so you end up hitting that same point. Okay? Listen, these should be easy. Should be. But because they should be easy, people rush through them, make silly little mistakes, and get it wrong. Okay? So I'm just forewarning you. Next one. Where is this point in relation to the pole? Due west, yes? To the left? So we're trying to reach that. How much should I rotate? Pi. I mean, you don't have to, but if you want to face towards the point, rotate pi. And what do I put here, 6 or negative 6? Because I'm facing the point. This is the one people really mess up on. They just really want to put a negative sign in their answer. But you can if you want to. But the normal way to do it is rotate towards it and then use a positive radius. If you didn't rotate, then you compare that with a negative radius. That would work. By the way, if I use 2 pi, wouldn't that also face away from the point? Right? Wouldn't, by the way, just while we're working this one, wouldn't negative pi be another way to face towards the point? So just like to think it through, don't make some mistakes. If you're facing towards it, use a positive radius. If you're facing away, use a negative radius. Then the last one, we want to face due south, so 3 pi over 2 would face us towards that point. Because like I said, that point is due south. And so pair that with a positive radius. Or face due north, away from it, use a negative radius. What if I put this angle? What do I pair with? What do I put here? 5, because negative pi over 2 faces due south, faces towards the point, so use a positive radius. Okay? All right. That's the front of the homework. Now for the back, same formulas, but now we're converting equations. I'm just going to do a couple of these, really 2 at the very most. Let me say again, when you're trying to choose which formula to use, what you want to do is focus on one formula. If you're not certain, let's say you knew rectangular, so you knew x and y. What I want you to get is if you look at this formula, if you know x and y, if you plug in x, you still have 2 unknowns. That's no good. If you have this formula, when you plug in x and y, you have 1 unknown. That's good. You plug x and y here, you have 1 unknown. That's good. Okay, so that's how you kind of choose the formulas. Now, find this one. Here, this is easy. X equals r cosine theta, which means this is just x. So the equation is x equals negative 3, which is a vertical line. Done. The next one's a bit more challenging. Listen, first of all, if you have r squared, we're trying to go from polar right now, okay? So if you have r squared, r can be replaced, r squared can be replaced with that. Now, the other thing you can do is r cosine theta. If you had that, you can replace, oh, that's right. Oh, well.